Alright, that was straightforward. Although I said division is not going to be so straightforward. That was partly a lie. Because in the polar form, division is just as simple. Division is just multiplication by the reciprocal. So you raise it to the -1 power. That means you simply divide the lengths. And the angle gets a negative sign. That means it's going in the opposite direction. It's going in the negative direction. Or negative orientation, I should say. I keep mixing these two up. Basically, orientation is on the circle, while direction is on a plane. That's a rectangular thing, or 2D planar, or linear, whatever you want to call it. At any rate, you should be reminded to the number I, when dividing by it was equal to -I, which was just turning the other direction. Now this works exactly the same way. And god damn it, I said direction again. Anyway, it is shrink and turn. And now moving on to the rectangular representation, you see something strange. What the heck is rationalization of the denominator? Well, that comes up because in the denominator we have a complex number, and that has the I part, the imaginary part, and we don't really know how to divide by I, at least not in the number theoretical sense. So to avoid that problem, something called a complex conjugate was invented. This is not the only use of the complex conjugate, because that's one of the most useful things you ever find in complex number theory. Nevertheless, this was the reason why it was invented. It's something like a reciprocal. It's a pair to the number. Conjugation keeps the real part unchanged and the magnitude of the imaginary part unchanged, while it reverses the direction of the imaginary part. That keeps the angle the same, but it reverses the orientation in the angular representation. So we attained the same result as before, but now we're getting it in a rectangular sense. In essence, it describes a reflection using the real line as a mirror. Here are a couple of examples. The conjugate of e to the I minus omega t would be e to the I plus omega t. 2 plus I will have 2 minus I. 6 minus 4i will have 6 plus 4i. That's pretty much it. The reason why you need to know and love the conjugate so much is because if you multiply the conjugate with the original complex number, then you get a real number. Plus I and minus I will cancel out to 0, and you only have the real part. So this comes up in electric engineering and physics and chemistry, everywhere where they use this level of math. And this is the process they call rationalization, where you get rid of the complex number and you get back to good old real numbers that you can fully manipulate. They can be in the denominator, that's no problem. But before I get into division in the rectangular form, I have to take note of the fact that on this image I just showed you, there's an upper dash, a bar. So conjugate is noted as Z bar, but in sciences it's noted as Z star. There's no bar in there, there is star, mostly because in physics and particle physics the antiparticle is noted as the letter it is and bar, and star would be the complex conjugate, which is also used in this context because they would take something called a wave function, which is a complex quantity, and use its conjugate, where they have to note it with a star. And I am going to be using the star notation from this point on because I'm a scientist. That is also why my explanations are much more clear than that of mathematicians, because I'm not symbolic. I'm using these symbols to describe something. And in sciences, these numbers are used to describe cyclic processes. Hence the title, the cycle. You have these two numbers and you have that denominator that we don't like. So you have to multiply that number by the conjugate. But how do you get the conjugate into the picture? Here you apply the trick of 1. That's the cleverness here, because 1 is equal to anything over anything. You take the conjugate over the conjugate, that's just 1, and that way you can multiply the bottom by the conjugate, you just have to multiply the top by the conjugate as well. The rest is just math, just reformulation.